Hi everyone, this is a video for Yinsh project. Our team name is OMC number 1.
We implemented 4 techniques in this project. The first two iterate deepening search and A*. The way how ID works is that it will try to return an action of either formal sequence or random choice. A* is a heuristic function to get its search to return the best action for the current state. The heuristic function we designed is finding the minimum steps needed to form a sequence for each 5 available positions. The last two techniques are multicolor tree search and approximate Q-learning. MCTS will simulate the games and constantly update to get the final result. It will return the best action based on that result. Approximate Q-learning can store both offensive and defensive features of game state as well as corresponding weights. It can return the action to interrupt opponent's move. In the final tournament, we choose the approximate Q-learning function as our final technique.
We can see that ID search is not suitable for these games because it's high time complexity. It can easily lead to the timeout problem, then return a random action. The first video shows the advantage of the A*. It can use the heuristic function to guide the search. However, the second video will well demonstrate the weakness of A*. The A* cannot simulate the opponent's agents and react to defensive actions due to the time limit. It is easy to lose the games in this stage. Recommended rules of the multicolor tree search are not that great where the algorithm starts, because it's less simulations. We can see the multicolor tree search is easily loose and the action it takes are not very reasonable at the beginning. However, while the statistics about the simulated scam are constantly updated, it could return better and better action. We can see this in the second video. We firstly apply a basic approximate Q-learning, and we find some challenge that prevents us to achieve a better performance. The challenge will be wasteful future selection, inaccurate heuristic function, and inaccurate future rate implementation. And of course, we tried our best to solve them. Let's see how we're going. Our basis approximate Q-learnings can only consider heuristic functions and counting numbers as future as start. Then considering opponents' actions led to the opponents can easily complete their sequences. Then we add the features of the opponent's heuristic, which means we can use other rings to block the sequence of the opponent. It helps us to not only complete our own sequence but also destroy the sequence constructed by the opponent. Secondly, inaccurate heuristic function lets us lose opportunity to defeat opponents. However, while we apply more accurate heuristic function, the action not only consider how to complete the canvas sequence, but also considering complete the next sequence.
Future rate change is our final main improvement. It has a huge effect of our approximate Q-learning. In this video, it's with to focus on our heuristic to ignore the situations of components in current gamble. It will lead us to lose the games. However, applying more accurate weights by chaining thousands times can find the balance weight on designs when to complete the current sequence and destroy the opponent's sequence at the same time.
There are some additional workable development that we apply. Firstly, our agent tried to put each ring near to the counter. Secondly, based on the initial position observation in the Floyd website, we get a great improvement. However, our agent only used the single player training at this stage because we implement multiplayer unsuccessful. In the future, our team will try to consider multiplayer because it can train our feature way better than achieve better performance. Also, our heuristic function can consider more steps to adapt. That's all. Thank you for your watching.